Alrighty guys, it's obvious that I am not here today, so I'm going to teach you how to do this with a video. So we're going to do angled projectiles. You should have this paper in front of you. We kind of talked about this on Friday. We have a parabolic arc. We're going to use V, and we're going to break it into Vx and Viy using theta and trig. As we go up, gravity slows down the projectile at the very, very top. Vf in the y direction is 0, just like with throwing things up in the air. And Vx will always be constant. So as you look, as the ball goes up, Vy changes, but Vx does not. That's why we did vectors, so we can take a look at these vectors and figure out how fast the ball is going at any given point, and we can figure out where the ball is at any given point. Okay, so some vocabulary you need to know. You can read that. I'm not going to bore you with that. Rules. Okay, if you follow the rules, these problems are very, very easy. If you follow the steps, these problems are very, very easy. So first rule, make sure you're in degree mode. If you changed your batteries, your calculator is not in degree mode, so go check it and change it if you need to. You must break up the launch velocity v into Vx and Vy. Here's your equation right there. Vx is V cosine theta, Vy is V sine theta, and this is Viy, the initial velocity in the y direction. At the top, Vfy is 0 because of gravity. Vx is constant, just like the picture says, the whole flight. At the top of the trajectory, the projectile is at the highest point. We're halfway through our flight, and then once we know time to get to that halfway point, we just double it. These flights are always going to be symmetrical. We land and launch at the same height. Okay, so here's our formulas. These are really nothing new, they're just rearranged a bit. Vx and Vy we already gone over, so we're going to do that first. Solve for time to get to the top of the trajectory. So here's how you do it. Time is Vfy minus Viy over gravity. And we're still going to use -10. Once you have that time, you can solve for your max altitude. And we're going to use dy equals Vit. And this is going to be in the y direction, plus 1/2 gt squared. Then we double the time, and then we solve for range using Vx and that doubled time. Okay, so there's the formulas if you didn't see. Okay, so here's an example problem. There's Bob again. Bob gets around. Notice we have our chart. Okay, so we're going to do a couple of steps to put variables into our chart where they go. So Bob kicks a soccer ball at 15 meters per second at an angle of 25 degrees upward. Okay, so little sketch. All of our sketches are going to look a lot alike. There's 25 degrees, there's V, there's our dy, and there's our range. And up here, Vfy is 0. Okay, so step 1, we have to figure out Vx and Viy in order to fill that into our chart. Okay, so Vx is V cosine theta, Vy is V sine theta. So my V is 15, that's our launch velocity, times the cosine of 25 degrees. That's going to be 15 times the sine of 25 degrees. Okay, so in my calculator, 15 cosine 25 gives me 13.59. This is the velocity in the x direction, and this will not change through the whole flight. This remains constant. So that goes in for Vx. Remember, 2 decimal places. So Vy is what's going to change because of gravity. So I've got 15 sine 25. And that gives me 6.0 6.34 meters per second. So remember, with horizontal projectiles, we didn't use VIY, it was 0. Now it's not 0 anymore, it's a number. At the top, VFY is going to be 0. Gravity's still negative 10 meters per second squared. Okay? So we've done step 1. We solve for Vx and Vy. Step 2. Solve for time to get to the highest point. So how long does it take to get from kicking to up there? So T is Vfy minus Viy all over G. Well, at the very, very top, we know that Viy is 0. I'm sorry, Vfy is 0. Viy is 6.34 meters per second, and gravity is negative 10. So that gives me a time of 0.634 seconds. So that goes in right here. Okay, now this time and this time are no longer the same, because this time is the time to get up to dy, and this big T is going to be the time it takes to do the whole flight, and that's dx. Okay, so step 3. Solve for max altitude. dy Viy t plus 1/2 gt squared. Okay, so I look at my chart. The Iy is 6.34 and my time is 0.634. Plus 1/2 times negative 10 times 0.634 squared. Okay. So in my calculator, 6.34 times 0.634. That gave me 4.01, but I'm going to keep all of my numbers in my calculator. This is really going to end up being a minus. So 0.5 is the same thing as 1/2 times 10 times 0.634 squared. 2.00978. So that minus that gives me 2.00978. So to 2 decimal places, 1, 2, we look, we need 2.01 meters. Okay, so step 3 done. Step 4. Step 4 says double the time. So 0.634 times 2 gives me 1.268 seconds. 2 decimal places, we round up, so that's going to give me 1.27 seconds. So that goes in my chart for dx's time. And then step 5 says solve for range using Vx and the doubled flight time. So range is Vxt, 13.59 times 1.27. That gives me 17.2593. We look, that's going to bump up 17.26 meters. Sorry, you didn't see any of that. I apologize. So there's my formula. Range is Vx times t. There's my Vx. There's my t. I got 17.2593. Look at my 5. Rounds it up. 17.26 meters. Okay, so I filled in my whole chart. We've done all of the steps. Letter D says, where is the ball 1.1 seconds into its flight? Okay, so I can make an entirely new chart and solve for that using those two times, because I want to know where it is in height, that's dy, and I want to know where it is in range, that's dx. Okay, so t, dx, vx, t, dy, diy, fy, and then g. So this is just like we did with horizontal projectiles. The time I'm going to use for both of these is 1.1. I'm not going to double that. I want to know where the ball is at 1.1 seconds. So since the whole flight took 1.27 seconds, 1.1 is going to be somewhere over here. Okay, so we should be pretty close to our maximum range, and we should be way lower than our maximum height. So we're on the way down. Vx is still going to be the same. So that's still 13.59. Viy is still the same. Okay, Vfy I'm not going to worry about, -10. So I'm solving for dx and dy. And I'm going to solve them exactly the same way. Dx, or range, is Vx times t. So 13.59 times 1.1. That gave me 14.95 meters. So we're pretty close to landing. Our full range was 17.26. We're almost there. So now dy is going to be Viy times t plus 1/2 dt squared, because Vi is no longer 0. Vi in the y direction is a number. Okay, so 6.34 times 1.1 plus 1/2 -10 1.1 squared. .974. This is going to be a minus because of gravity. .05. And that gave me 0.924 meters above the ground. So we're still in the air. And I'm going to leave it as 0.92 meters because that 4 doesn't bump up the 2. And that's all there is to it, guys. Have fun.